All right, since everyone here is ready and good to go, so you guys ready? Are you ready? Okay. All right. Don't spit at food. Don't spit food at me again. All right. Okay, that was bad last time. All right, class.
Yes.
So pretend like you're excited, Denny. Are you pretending pretty well? Good. All right. This is we have 3 lessons left to finish. Okay, area between graphs. So now we're going to find the area in between 2 graphs or given bounded areas to go along with that. So instead of just finding regular, it's going to make it weird. So finding area between the graphs of 2 functions by partitioning the x-axis. So when you find the area of the curve, if you were to find the area of the blue one here, okay, the blue line, it would be from the blue line down to the x-axis. That would be the area. But we are finding the area in between the 2 curves. So instead of actually doing that, I have the red line, which is the area of all this down here. All this area would be area underneath the red. So to figure out what would be in between, it would be the blue one minus the red one would give me just the area in between those 2. So a lot of things that you have to do, and you have to understand, okay, which function is on top? That's important. So when I'm looking at this and I'm only given the functions, which one's going to be on top, which one's going to be on bottom? Which one is, where are they intersecting? Because sometimes they're going to intersect. You're going to have something that goes like this, and then you're going to find the area here and the area here, just in between where it changes to be, top, and then right here changes to be on the bottom. Does that make sense? Alyssa?
Yeah.
Good. Did I have 2 of the exact same one? Yes, I do. That's weird. Anyway. All right, area of the region enclosed by the graphs of f of x and g of x, and the lines x equals a, x equals b, where f and g are continuous, so the interval from a to b, and the f is greater than g. So that means that the top one is going to be f, and the bottom one's going to be g. So from there, and my interval would start at from a to b in between both of these. And so this one does not change in between any point. So there's no change in the graph. So it doesn't go from G being on top. Find the area A of the region enclosed by the graphs of e to the x and square root of x and the lines x equals 0 and x equals 1. So if I were to take a look at this, I would go, start here. So x equals 0 and x equals 1. Square root of x. Square root of x is going to look something like this. And I'm going to start with that one. So square root of x is going to look like this. And that goes to 1. And then e to the x is going to go 0 here, and e to the 1, 2 point something here, like this. So it's going to look something like this. This is my e to the x, and this is my radical x.
Very bad parallel.
I know, very bad graph because I
Wow.
suck at drawing, don't I?
It's a very bad parallel line.
And since you hate my drawing so much, let's go ahead and show. So if you have your calculator, so my first one was e to the x. Hit enter, and the next one is hit tab, and it is square root of x. Enter. let's go ahead and, since it does look something like I did draw, menu, window, let's change this to be, let's go -1 just so I can have a little bit of wiggle on this one. And X max would go to 2. So we're finding the interval in between here and here. So given that graph, I know that my e to the x is on top. I'm taking the from e to the x minus my lower, which is going to be x to the 1/2, and this is going to be a dx, and my bounds for this one is going to be between 0 and 1. So let's integrate. This is going to give me e to the x, and this one I add 1. So that's going to be 3/2, right? Yes, 3/2, and then I divide by 3/2, or multiply by 2/3 x to the 3/2. From 0 to 1.
I keep forgetting.
Keep forgetting what?
I still have the habit of just keep doing the derivative.
Oh, okay.
I'm like, oh god.
All right, there we go. And so let's go ahead and do the math on this one. So this one right here, the lower bound, is going to be e to the 1, and that's going to be minus 2/3, minus the lower bound, which is e to the 0, minus 0. Did I go too fast on that one? Alyssa, how'd I get 0? Plug in 0 for the x.
No, look at the 1.
Oh, you got a problem with the 1?
I just looked at it.
Okay, so for the 1. Okay, so if I plug in the top right here, it's going to be, what's the square root of 1?
1.
1 to the 3rd power
1.
times 2/3.
2/3. Okay.
Okay, and then when I plug in 0,
0.
yeah, all that goes away. So this whole thing's going to come out to be, let's see, so e to the 1 minus 2/3 minus 1.
Hold on. Do you want decimals or do you want
It's going to be a decimal.
okay.
Or actually, you could have it as a e.
It's like negative.
That would be like e to the 1. E to the 1 minus, what's that, 5/3?
I thought it's like minus 2/3.
Because you also have to subtract the, what's e to the 0?
1.
1. So I added those.
Oh god. Parentheses. E to the 1 minus 2/3. Close parentheses. Minus 1.
Okay, so now let's take a look at what the calculator does. Calculator is actually kind of neat because it will do all kinds of weird stuff for you.
That's what I'm doing. I put 1, but
Now, so menu,
Okay.
and let's go analyze graph, and I want bounded area. There's integral, which goes all the way to the x-axis, is bounded area. So let's see. Lower bound is going to be 0. Upper bound is going to be 1.
How do you give the bounds? Because usually it can force me to do the scroll thing.
Just type in the number.
Type in the number.
Just push the number.
Because I tried that. It wouldn't let me. Okay.
And where it says lower bound, just enter the number. Just push the number.
Okay.
Did you get it?
Yeah, I got it. Man.
All right, so that's with that graph, and then let's go out here. And on yours, it will be menu. We're going calculus, and we are new. Actually, you have more options on yours, but numerical integration is going to be the same. So from 0.
Where's the numerical integration?
Menu.
Oh, is it the first one?
Hold on. Menu. Calculus. Just go integral.
Integral? Okay.
Yeah, because these your calculators will do more
Oh.
than what I have. And this is e to the x. Arrow over. Minus square root of x, comma, that's an x, and then dx. Is that the same thing we got earlier? 1.052, 1.052. Now, will the calculator do most of the stuff for you? Yeah. I still would like for you to actually try to integrate this by hand to show your work on this, because yes, you can get the answer on this for this program here, but on the AP exam, you will have to just write it as like what we have right here. So simplify to e to the 1 minus 5/3. Does that make sense? No? Maybe?
Yeah, I just hope I
Yeah.
don't make into derivative.
Yeah. Don't. Just don't do it then. Just don't do it, because you know how to read.
The only thing that gets me is the dx, and it's just make me think of derivatives.
No. Bad. No. Nah. Anyway. All right, so let's try another one. So here's a nice graph of all this, and they have pretty graphs on theirs. I don't have pretty graphs on mine because I suck at drawing. Find the area of the region enclosed by the graphs of these two things. So, first thing I'm going to do is I'm going to graph, and it's going to be the region enclosed. That means if it's enclosed, that means that these two lines are going to be intersecting at 2 points. So that's what that means. So 10x minus x squared. So to clear this up, just hit doc, letter B, go back to here, minus x squared. So there's my first one. And the next one's 3x minus 8. Hit tab. 3x minus 8. There's my next one. And a couple things you could do. So if you notice, I can't see this right here, right?
Yeah.
So a couple things, you could actually grab the screen and move it over. So just click it on this. Just hold it until you get a hand. And then you could actually move it. So that's one way of doing it, but it's still not going to show me where they're cross. But I know it's crossing down here at like -10. It is crossing up here at like +20. So let's menu, window. Let's go. Okay, so the X values I think are okay. The Y values are not. -10 and +20. Let's see if that shows. There we go. I actually do have both of them there now.
I don't even know where that's going.
Hmm?
You count the intersection at the bottom, or you?
I did not get the intersection. I need to move it down again.
Okay.
And I want to move it up again because I still don't see all the blue here.
Can you just do window like fit, or would that not work?
It works sometimes.
Sometimes.
Do you want to try it? Okay.
Does that work? Okay.
Yeah, it'll work.
There are some cases it won't.
Yeah, sometimes it like makes it super weird shaped, but this is all we need is to be able to see the two places where they intersect, right? So the word enclosed mean it's going to be bound in between here and right here. Let's get the calculator to tell me where those are at. Menu, analyze graph, and I'm looking for intersection. So lower bound, so somewhere over here, you could just move this left and right, just move to the left of where it's crossing, upper bound, and it's going to give me that coordinate. Again, menu, analyze graph, intersection. There we go. So now I'm going to write this out as my integral. So my 10x minus x squared is going to be the top. So this is going to be the top one minus the bottom one here. So let's go ahead and from -1 to 8, let's write my integral. Now, you notice how I wrote this here with parentheses, because I need to subtract the entire integral. That's important, because if I just put a minus sign, minus 3x minus 8, that one's not going to help me out, because I have to subtract the entirety of the function, or I could rewrite it in two separate, as -1 to 8 of 10x minus x squared dx minus the integral of 3x minus 8 dx from -1 to 8. Now, let's go ahead and see how the calculator will go ahead and plug it in. So I'm going to do the same thing with the bounded area. And my lower bound is going to be -1. Type in -1. Enter. And my upper bound is going to be my +8. Just hit the number 8 and hit enter. Yes, no, maybe?
Got it. 121.5.
Did you not get it?
Oh, sorry, could you repeat it?
Huh?
Could you repeat
Do you want me to redo it? The whole thing? Or just that last part? Okay, so menu, analyze graph, and we're doing bounded area. So is it say bounded area on yours?
It says bounded area.
It does? Okay.
Yeah.
Like I said, you guys have a better calculator than what I have on my screen here.
They're like, can't you just upgrade it or like?
No. Because I bought your calculators with a grant, but the school bought this software, and they only went with the generic software.
Huh.
So even though it's still really good, but so I went from right there. So now I did that. My lower bound started at -1. And then I could just trace it over. Yeah, don't try to like line it up like this, because that's really hard. Okay, to line it up like this. So if you do the exact, just push the number, and that's why we get that exactly every time. All right, does that make sense? Yes, no, maybe, possibly, on occasion. Denny, you good? All right, that being said, I'm going to leave you guys here today because today is that weird schedule. All week long, we have NWEA testing. So I'm going to leave off here. So make sure you like, share, and subscribe. Hit that notification button. Work on some homework.